welcome to today's show. I've been really busy lately, haven't had much time, but I'm still alive. Today we're going to do something pretty quick. It's getting late over here. We are going to be able to build our project all through the command line interface, so we won't have to open up Visual Studio in order to compile and run our project. So that's going to save us some time. We're also going to set it too so that we don't have to run CMake again every time that we want to build and run our project. So as long as we don't change any of the files, or we don't change where the files are, the file names, the configuration in that regard at all, then we can just build it. So here we go. Let me share my desktop. Last time, I've already done this, so I should be able to do it a bit faster this time. Unfortunately, I didn't share my screen, so I deleted that stream. I didn't die. I just deleted my stream. Okay, so I've got our project open, AI art generator. As you can see, Control tilde, I'm in the terminal. I haven't made any change. All the changes I made, I've reverted. I saved them into another project for reference. But we're starting off right where we ended on the last stream that I didn't delete. So here we go. Just as a refresher, we've got two types of building scripts here on Windows. We're on Windows, so we're using batch scripts. We've got debug and release. So what they do is they completely delete our build folder, which is good to do with CMake. Sometimes you'll make changes in CMake and then you'll run CMake again, and because of the caching from the last time you ran it, it'll keep some of those and it can kind of mess things up. So it's better if you re-CMake, always just delete wherever all of your build configuration files are going. So we delete our build file or build folder, then we recreate the directory, we change directory into the build directory, and then we CMake. We pass in a build type of debug. This debug build type, we have some switches in here for. We've got a message saying we're building in debug. The real magic though is that we set a compile definition underscore debug. Visual Studio will automatically do this. So within our code for debug sections, we want to rely on underscore debug. And also when we're on Linux, where it doesn't automatically do that because you don't have Visual Studio, if you're using GCC or Clang, it'll set this for us. So we can always depend that if we've got this defined, then run the debug code. Compile options 2, NVCC by default, it's not in debug mode. Instead of a lowercase g like you would use for GCC or the other C++ compilers and C compilers, for NVCC use a capital G. So we pass in and we'll have the debug version of our CUDA code compiled. So once we run this, and I'll run it, we will generate our build configuration files. By default on Windows, it'll make a Visual Studio project file. Solution file is what Visual Studio calls it. So you can see here, here's our solution file, extension .sln. And we've also got a VCX proj. This has a lot of configuration in it. It's got to be in the same directory as your solution file. And this has everything we need. So actually, when we build from the command line, we're only going to input this file. So in order to process this input file, we'll use another Visual Studio tool. So Windows Z, open up our Desktop Explorer, C drive, program files, and not Visual Studio, it's Microsoft Visual Studio. Go here, 2022 community. Let's see, where is it? The file we're looking for is called msbuild.exe, not xer, xe. So we have a few of them pop up. One is in the AMD 64 folder. That's what we want. Everyone's got 64-bit these days, and we want it as fast as possible because we're doing machine learning. So we go to this folder, AMD 64 MS build. Here it is. Now we can just hold shift, right click, and copy as path. Now in our project directory, in our root directory, we'll make another batch file to run this. What should we just make it the third option? We might have an option 3 and 4 for CMake build and run instead of just build and run. And we'll put our Linux files later. We'll probably put all our Linux config files. We'll start them with a 2 instead of a 0. Let's just make it file number 3. We start these with the file number. We start these with a number so they're organized together, and it's also much better for autocomplete. So we'll say Windows build run. We'll do only debug for that. Debug.bat. So we've got our MS build executable here. We've got spaces. We can't have because we installed in program files where it would default install. It's gonna have a space in it, so we put the double quotes around it. MS build, and then we point to our vcx proj file. So copy relative path, and we point to it. The CMake, it's working out of the directory that it's in, which is our root directory for the project. So build the AI art generator via vcx proj will find our project for us. And then after that, we want to actually run our beautiful thing. So build, which I think we'll use the Windows directory delimiters, I think. Build, debug, and then our executable name will be the same name as our project, which I'll click on here. Project name, AI art generator. And I think this will build and run it. Let's check. Building, let's see. Oh, we got the CUDA compiler. Then comes the C++ compiler, and then the linker. Yep, so we got the linker last. Linking warning. libcmt conflicts with the use of other libs. I don't know what this is. I saw this last time I did it. But I will put this in my list of things to do. I've got a list of fun things to do and boring things. This is a boring thing. Put it in here last time. Look up what libcmt is. So you see here, build succeeded, one warning. That's our linker warning. Time elapsed. And our executable ran. We've got our output here. We still have the problem where it wasn't outputting the thread print statements because we're using too many blocks for our for a cooperative group kernel, which is a CUDA bug we found out. So I'm still yet to post this issue to the CUDA forums, to the NVIDIA developer forums. But I'm going to do that before I talk to my company's representative. They might be able to just address it there. If they don't do it, then I'll talk to our company's NVIDIA representative. Press any key to continue. So we had this press any key to continue. It's actually in our program because we wanted to keep the command prompt of it when we ran it through there. But now that we'll just run it through our VS Code command prompt, we don't need that in our code anymore. So go to root of my source and get rid of this system pause, which is good. We get rid of this ugly Windows ifdef. And now our executable will close when it's done, which is also good because then we can modify the executable externally without having it say that it's being used by another process. And I can show you here. So I changed the code, but I didn't rearrange files or anything like that. So I'll build it again and run it. And there it goes. So now also too, we'll go over the bug last time that we saw. We're running 180 or 128 threads per block, and we're running 256 blocks per grid. Grid's the final scale, final unit. So we're running 32,000 threads, and we're running it with a cooperative kernel launch. So for some reason it doesn't like that. Documentation says that this should be up to 2 billion, so they're a little bit far from what they said they would be able to do. If we do 128 blocks per grid, it should print as we found out last time. So I changed it and I'm building it. See, this is so much easier. Look at that. Got to 16,000. Got close to it. Sure, it got all the way there. Yep, here we go. And this is when we run this, it's gonna run our debug version of the file. So let's go ahead and make one for release. So I'll just take the file name here, boom, paste it in again. This time it's release 04. Just checking my live stream. Yep, had some audio coming through good. You can kind of hear my mouse. Let me know in the comments if I should, if anyone thinks I should get a mouse pad. If not, I won't, because I kind of like be able to move my mouse all over, you know, those 360 no scope headshots. Okay, so take a code and we'll do release version. All that we're changing is the executable we're running, the folder that's in. We got to be careful because if we build release with, say, like our second batch file here, we could maybe someday accidentally then run the debug, and then we'd be running an out-of-date executable, and we could be thinking we're having something wrong or something didn't update when it actually did. So we'll have to be cognizant of that. So anybody just start chatting in all caps if I do that. Okay, this was really easy. I have been busy. I didn't think I would do this fast, so I guess we'll move on to a next task. I still have a little bit of time tonight. We've got our root folder here, and we have the root of our source code. Let us add in another folder starting from the root, and this will be our mnist. handwriting test. We'll write all of our image classification architecture in this project, and we'll write in such a way that it's scalable, and we'll basically make a framework for it, and we'll make sure it all works. We'll run all kinds of tests on this smaller architecture. It doesn't have to be that big because it's only reading handwritten letters that are, or numbers that are, it's just single digits of numbers that are 28 by 28 pixels. But yeah, we'll test it out, and then we can grow it huge so that we can start classifying actual pictures, artwork. So we have MNIST here. We're going to have our own main file to test our kernel with. And we'll have a file. What should we name this? MNIST neural network. I think that's pretty clear. Pretty clear what's going to be in that file. And we'll make our CUs. So in our HPP, remember, always want to include guards. So pragma unst. We can right click it, get the relative path, and be sure to include it here. Include. So we put in the double quotes if it's a project that, or if it's a file that we made within our own project. And then we'll make sure that's in our main file here as well. You know what? Let's prefix our main file to or do we have to prefix these or in their own directory? We'll prefix it. That way if we have if we don't, then when we open up a main.cu from our real project, then it'll show you the entire path to it at the top on the tab name for both files. So it just kind of clutters things. So we'll just put a little prefix in front here. I always like to over comment and say that this is from our project, even though they know it because it's double quoted. So we'll go into CMake and we will point to our main file, all these files here. Well, at least our implementation files, the .cu ones. Okay, so we're gonna pass in, when we run our CMake, we'll pass in a flag to say if we're going to build our MNIST project or if we're going to build our actual project. And we'll just call it MNIST. Okay, so we'll say if MNIST we'll just name it MNIST. We're going to have an entirely different project name. And we will have, I guess we don't want to duplicate our code here. All right, so we'll change the project name. Still using CUDA and C++. Oh, we need, yeah, languages is there. We'll print our project name. And we'll still have normal debug and release for either or. But what does change This is when I was trying to fix an issue earlier. I put the sources variable in, but we don't need it. What does need to change is we're not going to build this main file if we are in MNIST. We will have our own target sources. Okay, we'll indent these for clarity. We will still have our error checking in, meaning we'll put that later. So outside of our conditional statements, we want our error checking, which is good. We can check our error checking even with our test project. So mnist main.cu, copy relative path, and we'll throw it in there. And we'll use Linux directory delimiters. Oh yeah, also we'll want to include our mnist neural network implementation file. Is that it? Is that all we need to do in this file? I think so. Okay, so next we need new batch files. So do this 05 Windows. We'll do for this one, we will CMake run. We will CMake build and run in MNIST debug version. So all we did was we had a little flag in our file called MNIST. So we just do -d MNIST. That's how CMake works. And then we want to run it. It'll have its own name, MNIST. And here we go. Let's try not removing the directory. Oh, by the way, if you look in the terminal, it's got a PS here through VS Code. That means it's running in PowerShell. And PowerShell uses a different syntax than what you use when you run a Windows batch script. But because we're running a batch script through the PowerShell, we use the batch script syntax in our batch files. So the command prompt and PowerShell will both run batch files the same. So yeah, there's problems. There's syntax mismatches. PowerShell commands, a lot of them do not work in batch files. And I don't know PowerShell, so it works for me. All right, we'll try number 5. We're having an error. Oh, we have to set it to a value. Okay, this is different than compile definitions, where you don't have to do that. I'm saying mnist.exe does not exist, so let's see what happened to it. Build, debug. Oh, it's still naming it AI art generator. Do we have to have it like if mnist equals 1? Project name should come from here. Let's double check this. Steve. Let's see how I do with my other project. C make list. Oh, I don't do this necessarily. What about in my Linux? I don't pass any flags into CMake on these. So we don't have an example for that. What could be the issue? We'll just try to... We'll remove our build folder. And we'll see if it still comes up with that name. Oh, we've got to make our build folder because we're no longer doing that in the script. Let's put some messaging in here. Oh, we have the message. Project name. Project name MNIST. See in our build file. mnist.vcxproj does not exist. Au contraire. Okay, so it's because we are in the build folder still. In our batch file. So we'll go to the build folder. Now let's jump out. Oh, look at that building. We have no entry point. That's strange. We don't have an entry point, so it shouldn't be running this code because this should not be included. Let's look at our CMake list. If MNIST... Oh, I have this backwards. You can just highlight lines and then hold Alt and press up and down, and it'll move the lines up, back and forth. Up and down, I mean. Okay, let's try that again. Should say something, probably a compiler that there's no entry point. Error, unresolved, invoke main. Yeah, so it's saying unresolved external symbol because later this gets, what do you call it? It's where you have like a weak attributed function and then you override it with another function. In this invoke main, it's supposed to get a function that overrides it. No errors? Don't do anything, no errors. We can... we'll have a little kind of debuggish statement for our main file for now. Include IO stream. Too late to type. And we'll try it again. It succeeded last time. Sweet. And we'll say that it's MNIST. Let's put a little line like that in our regular one. And let's make sure that our regular CMake still works, the one without MNIST. And we'll build and run it. All right, still working, except for the bug. It's not my bedtime yet. Still got a few minutes. Oh, work today. Rough. I did take a nap at work. Oh, it was awesome. I have a minivan, so I just get to go out into the parking lot and sleep, and it's not summertime, so it's not too hot. I've got a sleeping pad in there and a pillow. Makes me want to go camping more. It's pretty easy. You just flop down in a van, wake up the next day. So all this property stuff, we'll put this in another file. We'll make a utility file. Just GPU info print. I think we have to include CUDA runtime in order to get these functions, which I think means we need to have it a CU file for NVCC to see. We'll try it either way, actually, just to know forever, because we're scientists here. We'll be printing stuff, so we'll need IO stream. So make a little function here. Info print. We don't need to pass in anything because the GPU can just check itself, get all the info it needs. Oh, we want to implement it here. We might be including this in different places, like along a whole chain of places. We probably won't be, actually. But we will have an implementation file just to look nice for tradition. And we will return int, actually, because if the GPU is not up to snuff, they'll want to know. Standard library. All right, looks good. Okay, so we'll include a header. Why copy paste when you can type really fast? Oh, and then let's namespace it. Namespace it util. I don't indent my namespacing. It just makes it confusing when you have big classes. GPU info print. Oh, we need it here too. Oh, let's give it some breathing room. Get claustrophobic. Now, do we use any of this information? No. All right, there we go. We're not using device properties yet, but we could in the future. Let's be really clear for the noobs. Oh, we didn't put it in our CMake. It's not going to resolve the function. We'll use this in our MNIST test as well. Do we have any of these backslashes in our file? Oh yeah, we have them everywhere. Okay. I wonder if we could pass them in here with the Linux delimiter version. All right, build and run. Two errors. Did I not? I don't even remember. It just happened. I don't remember if I ran CMake after updating this. Oh, it's saved now. Okay, so CMake it again. And build run it. Up. Compiled it. Sweet. Okay, I guess I didn't CMake it after changing it. Warning. Not all control paths return event. Oh, that's right, huh? Nice little warning. It must automatically return 0 if you don't put that in. I'm surprised it does. That's not an error. It's just a warning. Okay, fix now. So CMake it. Why is this? Oh, whoops. don't put extraneous plus signs everywhere. Okay, now let's try the Linux directory delimiter and see if CMake doesn't trip out. Pretend it doesn't know what that means. Huh? Looks like it worked. Build. Yeah, okay. Cool. Now when if we put in like a bunch of files in and they're using the Windows format, we can just Control H them out of here, the replace. Okay, so with mnist we will also do our not test util GPU info print. I don't have the include file included. Include. Oh yeah, we're going to do we'll run batch file 5. All right, looks good. Let's just check, see if we can change this to a CPP file, and if we can still include CUDA runtime. While it's a CPP file. We can just do our main project for this. CMake won't make an error, but if there is one, it'll be at the compiling phase. Here we go. Yep, CUDA, all of these CUDA functions we called do not work. So now we know. Also, yeah, we can make our main file a CPP file if we just have to move our kernels, like all the implementation, into different translation units, so CU files, and we can make a main.cpp. Because I don't want to do any CUDA calls straight from the main function. We'll have it more abstracted. So we just have, in our main function, we'll just have like a list of all the functions we're running, so they can kind of read through like 20 functions and get an idea what's going on. And then we'll just use expressive function names so it's easier to follow. And then they can just F12 their way over to the details of the functions and go down whichever rabbit hole they want. All right. Yeah, this was a short stream. Glad it went so smoothly. And now it's time for me to catch some Z's. I might be working a lot tomorrow too. In which case I probably won't stream. Friday I'm going out, going dancing. But hopefully Saturday, if not tomorrow. All right, guys. Thanks for watching. Have a good one. Oh, it makes you confirm you want to quit. I could have just accidentally live streamed while I'm still sitting here thinking I'm not. Yes, confirm.